Hi everyone, can you hear me? Okay, so today we are going to start some like questions of DFS. So let me tell you the plan of this lecture series. So what we are thinking that we will be covering most important PYQs. So when I say most important, it means that we will be focusing on the PYQs which are relevant in every sense. So what do I mean by relevance? Which are most probably will be covering all the concepts. I mean the most of the concepts. So it will be covering most of the concepts. And when I'm saying concepts, it means it is also easy concepts. It's not like we will only be having difficult questions. We will be having easy questions. We will also be having difficult questions. So mainly we will be having difficult questions, but we will be also be dealing with the easy questions. So this lecture series is going to target all type of students who are basically just want to revise with the PYQs, which means like if you are facing some difficulty in some of the PYQs, then you can just focus on this series, and this will be definitely very much useful for all of you. Okay, so let's just continue. And okay, those who doesn't know me, let me introduce myself. I'm Sachin, and I'm instructor and co-founder at goclasses. I finished my masters from IISc, and after that I have worked at Amazon as an applied scientist, and I also got All India rank 33 in GATE. Okay. Like if you want to join our Telegram group for doubt discussion, then you can always join our Telegram group. That link is in description. So later if you have any doubt, then you can also ask in the Telegram group. So I'm telling in the upfront, right? And link is in the description. Either you can take the link from here, or link is also is in the description. And similarly, if you want to join our test series, then you can join the test series by going through this link, and link is in the description. Okay, so let's start with the topic, which is depth first search. Now, as I said, like depth first search, in this topic, we are mainly going to deal with the questions of depth first search. So, which means that I will not be covering the theory. I will be mostly be dealing with the questions only. So before that, let me quickly revise you that what does it depth first search like looks like. Suppose that you have a graph which is looking like this, and then in this graph, suppose if I say that run a DFS on this graph, then starting from A, let's suppose I say that starting from A run a DFS, then you will say that okay, let me probably from A, let me go to B, and then let me go to C, and after C tell me, can you go to some other node after C which is unvisited? See, from A you go to B, and then from B I am saying that you can go to C. So what my question is that after C, can you go to some other node that is not visited? Obviously you cannot go. So that is why you will say that you have to something called as backtrack. This is called backtrack, which means you have to come back to now tell me, you have to come back to B or A. So I just want you to revise this DFS so that you are more comfortable with the questions. Now tell me with these basic questions, if you are going from C, then you should be backtracking to B, or you should be backtracking to A. What do you think? I think you should be backtracking to B. Reason being is that like you have came from B. That's the point. So you have came from B. That's why you will backtrack to B. And then from B, can you go to some node which is unvisited? Then definitely you can go to some node which is unvisited. So you will be going to that node which is unvisited, maybe to E or to D. Let's suppose from this B, I am going to D first, and then from D, I am going to E. And since from this E there is no node, no new node I can visit, so that's why I will backtrack to D, and then from this D I will go to F. So like maybe this is one of the DFS tree that I can have. There are many other possible DFS tree that you might be knowing, but for the sake of revision, I am telling you that this is one of the DFS tree that you can get, and this is how you can backtrack. This is how you can just traverse in the DFS tree. Okay. So let's just continue with a few concepts. So we had in DFS we had a concept called discovery time, or some people call it start time and finish time. So like let's suppose that I'm starting from A, then suppose that I'm saying that discovery time of A is 0, then I will say if I go to this node which is let's suppose B, then this discovery time of this B is 1. So I will just increment the counter to 1 or something, and then I will say it is 1. Then here I will say it is 2. Now remember that whenever you need to backtrack at that time, you say it is a finish time also. So the representation that we are using is this start time oblique or slash finish time. So which means that whenever you are backtracking at that time, you write this finish time. Otherwise you will not be writing this finish time. right? Let me know if this is okay to everyone. So I hope that is fine, right? Okay. So if there is any doubt, you can always let me know in the comment section. If there is some video that my video is showing up, and if that video is overlapping with the text, then also you can tell me that the video is overlapping with the text, right? Or maybe I can place my video on the left hand side. There there is less likely that it will overlap. Okay. So I hope you are getting the point. Okay. Now let's move further. Now you can write the discovery time and the finish time easily, and then let's go to a theorem which is called Dfs Parenthesis Theorem. So basically the idea of this lecture, it will be just an half an hour lecture or maybe 40-minute lecture. Idea of this lecture is to do some previous year questions, but before that I just want you to make you familiar with this Dfs terminology. So like there is a finish time, there is a starting time, and these all, right? Okay. Now there is something called Dfs Parenthesis Theorem. I hope you might remember it from the lecture. If you do not know this, then don't worry about it. You can teach, like you can just go through this theorem later. That's given in the CLRS, which is Corman. So let me just recall you what does this theorem says. It says that if you are starting u from here, then there are only three cases. Either u and v, maybe something like this, which means u and v may not overlap at all, which means you are starting u from here, and then you are finishing u, and then you are starting v, and then you are finishing v. So it is basically start of u and it is finish of u. Similarly, it is a start of v, it is finish of v. So this is one case which is basically corresponding to balance pair parenthesis, right? Do you remember this? So it says that you are starting u, and then in between either you do not encounter v, which means you start u, finish v, and start v, finish v. And similarly, if you encounter, let's suppose you are starting u or v or whatever, if you are encountering in between, then in that case it has to be fully contained, which means these kind of cases are not possible, that you are starting v and in between you are starting u, and you can finish v without finishing u. It is not possible. And I hope that is very clear why it is not possible. Suppose you are starting v, suppose that you go to v, and then you somehow go to this u, you are starting u. Now how can you finish this v without finishing this u? See, you have to finish this u, right? Then only you will say that okay, I have finished this u, I will backtrack to v now, and then once you backtrack, you can say that now v is finishing, or something like that. So you cannot finish this v without even finishing this u. So that's the point here, right? So Virendra is asking, is it okay to watch PYQs if we have not solved them? Yeah, that's perfectly fine. You do not need to solve them first. You can just directly attend the session. Okay, so that's what the parenthesis theorem says. Now this theorem is very useful. You will see that how we are going to use this in the questions. Basically, this theorem is exactly similar to balance pair parenthesis theorem, where I say that this is a balance pair, and you cannot have these kind of scenarios where you are starting this and then you are ending this. In between, you are having different kind of parentheses, right? Okay. Do anyone remember this? At least those who are goclasses student. Do you remember this? This balance pair parenthesis or this parenthesis theorem. You might remember this, right, from the lectures. If you do not remember, then also it is fine, like you might recall it. See here, you are starting this u. Let's denote this start of u by this symbol, which is start of u. And then let's say that you are starting at p, and then you may start q, then you have to finish q, then you can finish p, and then it will be, let's suppose you are starting v, and then at the end you are finishing u. So that's how you are basically doing this in this particular graph, right? This parenthesis theorem is clear to everyone, okay? Okay. Now let's move further. So this is just one slide that we used. So suppose that you are starting S, then in between you may start Z, but you will finish it right away, and I mean before finishing this S, and then you will be starting this Y, you will be finishing Y, and like that, so on, right? Now there are many interesting questions that they can ask based on this parenthesis theorem, which means if you know the parenthesis theorem, then you can solve those kind of questions. First kind of question is that they may say that given these intervals, which is basically they are saying that v1, this is just v1, okay, this is just v1, this is v2, this is v1, this is v2, this is v3, like that, okay. So they may say that this v1 is basically having a start time of 4 and finish time of 5. Similarly, V2 is having a start time of 7 and finish time of 8. Now they have given the start time and finish time, and what they are saying that make tree using this start time and finish time interval. So this is first kind of question that they can ask. Given the start time finish time, they may ask you that what is the tree corresponding to this start time and finish time. Is this type of question is clear to everyone? That what they are asking? They are asking that you are given a start time and finish time, and then what is the corresponding tree that is possible. Let's just solve this question. See, what they are saying that let's say that okay, this V7 is starting first. What they are saying that V7 is starting at this point, which is at maybe time interval 1, and then this is V7. Now let's say that it is ending at maybe at 10. So let's say that this is V7. It is ending at 10 and this is V7. Now tell me in between who is getting started. This V6 is getting started, which is from 2 to 9. So you will say that this is V6 which is getting started, which is from 2 to 9. Now can you since the values are given, you should not get confused, but can you tell me that was it the possibility that V6 is getting started here and V6 can finish here? Was this the possibility at all that V6 can start here and finish after this V7? Is this even a possibility in this parenthesis theorem? Obviously no, right? This is not a possibility. Reason being is that that's what the parenthesis theorem says basically. It says that if you're starting at in this parenthesis or in this time interval, then you have to finish before V7 only, and that's what the values also says. So numbers never lie, right? So this is saying that V6 is getting started at 2 and then getting finished at 9. Similarly, V5 is getting started at 3 and then getting finished at 6. So maybe you can say it is 3 to 6 and V5. And is there anyone starting from 4? Yeah, V1 is starting from 4 and finishing at, let me just write with another color. V1 is starting from 4 and finishing at 5. So this is V1. This is 4 to 5. Is there anyone starting from 5? No. Anyone starting from 6? No. Anyone starting from 7? Yes. So V2 is starting from 7 and will finish at 8. So it will start from 7 and it will finish at 8. This is V2. Okay. So let me use this color. This is V2, right? Okay. I hope everyone understood that V2 start from 7 and finish at 8. Now similarly, which else is remaining? 1, 2, I think V3 is remaining, right? Yeah, V3 start at 12 and finish at 13. So we will write this V3 here. V3 start at 12 and finish at 13. This is V3. V4 start at 14 and finish at 15. This is V4. B5, I think we are done with B5 or no? Yeah, we are done with B5. We are done with V6, I think, right? We are done with V7. What about V8, which is starting at 11 and done and complete at 16. So it will start at 11 and complete at 16, which is after it. So this is V8. So can you draw this interval chart? Let's just call this particular chart as an interval chart. Okay. So can you draw this interval chart? I hope you are able to draw this. Now given the intervals, you just need to draw the chart. I mean there is nothing fancy we did, like we just given this interval we just drawn the chart, right? ठीक है, ये सबको समझ में आ गया? Okay. Now once you understood this, then can you make a tree? What they are asking is like this is first kind of question, the make tree using start and finish interval. Now can you make a tree? I think you can easily make a tree. How? This is V7, which means you will say that first of all this particular set of nodes are different from these particular set of nodes. So there will be not just tree, I mean you can say tree or forest basically. This will be a forest. So V7 is having only one child, which is V6 in the tree. This is a tree, not a graph, right? I mean you do not know how the graph looks like, but at least you can comment about the tree. And then V5 and V2. This is V5, this is V2. And then they are saying that V5 is also having one child, which is V1. So this is all about the set of nodes here. And if you want to draw the set of nodes here, V8 will be having two child, which is V3 and V4. Right? Tell me, can I also write something like this? Instead of this, can I write? I mean, this is one thing that I am writing for this V8. Tell me, can I also write something like this? Maybe given this, can I say that V8 is having one child only, which is V3, and then V3 is having one child, which is V4. Is this correct or this is correct? Which one is correct among these two? So I think the left one is correct. You cannot say that V8 is having the V3 and then V4. Obviously it is particularly wrong, right? So that's why you will say only the left one is correct. So this is correct. So that's why I will say this is correct and this is wrong. So I hope this kind of questions are fine to everyone, where they will give you the intervals and then they will say that, okay, can you draw the tree? This is first kind of questions. Okay? Now let's move to the second kind of question where okay, first of all, in this first kind of question only, they can ask you many different type of question, that what is the descendant and ancestor nodes of V6 and something like that, right? Once you make the tree, then I hope that everything else is easy to answer, because how many components this graph has? Can you tell me how many components this graph has? Given these set of values, can you tell me how many components this graph has? Very easy answer. How many components? Just 2 components, right? So just 2 components this graph has. Like, I mean, you can easily answer all set of these questions, right? Now let's move to the question type 2, where they will be given the DFS forest. So earlier what we did, we have drawn the DFS forest. Now they will give you the DFS forest and they will ask you what? They will say that, can you tell me what are the intervals that are possible? Can you draw me the interval chart? So these are the 2 different kind of question that they can ask. I mean, you do not need to mug up or remember anything. It is very easy to understand. Like, once you understand, then I hope things are very easy, right? So given this forest, now what they are asking, can you draw me a DFS intervals? Let's just see if you can draw. See, B is getting started, and then in between B, you will say that there will be A, and then you will say that there will be D, and then in this D, it is having E and it is having C, right? So you can easily draw the interval chart using this DFS forest. So for this, I think I might be having answer on the next page. Yes. So I have the answer here, right? This is very easy to draw. Let me know if there is any difficulty till this point. If there is no difficulty, then we can move further. Okay. If there is any doubt, सबको समझ में आ गया? ठीक है. So we are currently just revising the theory, which means like I'm just telling you that what are the kind of things are possible. And in DFS, generally in the books, what they say, it is visited or unvisited, and like we just categorize it using two things. Either it is visited or unvisited, which means if you are having a DFS traversal, maybe let's suppose if you are having this as a DFS traversal. So initially only let's suppose everyone is unvisited, then A will be visited, then B is visited, then C is visited, like that. And then some books or most of the books also categorize the visited into 2 parts. They say either it is gray, which means it is visited but not finished. Finished means मतलब आपको finish time नहीं पता. You do not know the finish time. You just not yet finished means you do not know the finish time. It has not backtracked yet, right? So only Ashish is replying. There are quite like 15 people and they are not replying. Can you tell me that if you are getting the things or there is any difficulty in understanding? So generally textbook just categorize this into 2 parts. They say that this visited is basically having 2 parts. One is not finished, visited but not finished, right? And another one is visited and finished also, which means it is here they have, I mean generally instead of having the 0-1 values for the visited array, like instead of having 0-1 values, they have 0-1-2 values, something like that. I mean 0 means let's suppose it is unvisited completely, 1 means let's suppose it is gray, and 2 means let's suppose it is black. So sometimes they also use 3 values. That's what I wanted you to revise this, right? ठीक है. Okay, Arnav, no problem. Now let's see the Dfs Edge Classification. So as you might be knowing, the given a graph, there are 4 types of edges that are possible in a directed graph for the DFS. So what are those edges? Tree edge, cross edge, forward edge, and back edge. So if this graph is given, then let's suppose you are starting from A, then tree edges are all the edges which are basically part of tree. This is tree edge. Back edges are from descendant to ancestor. So this yellowish edges are back edges. And then forward edges are from ancestor to descendant, which are not tree edges. And cross edges are basically having a no relation between B and G. Neither one is descendant of or another, or nor one is ancestor of another, right? So these are four types of edges that are possible. I hope you can recall. Now let's have two different kind of questions here also. So currently you know the Dfs Parenthesis Theorem, and there we have seen that okay, given a time interval, how to draw a graph or how to draw a forest. Given a forest, how to draw the time intervals. Now here also they will ask you that given the discovery time and all, like they will give you that okay, this is the discovery time and all. Like they do not need to give you the graph and all. They will just give you that okay, these are the discovery time and finish times, right? They will say that these are the discovery time and finish times. Can you tell me that how does what is the relationship between some particular edge? Let's suppose that this is u, v, something like that. They will say you that okay, can you tell me that this is the discovery time and the finish time for every of the vertex? Can you tell me the relationship between like what kind of edge it is? Like ub edge is a back edge, ub edge is a forward edge, or a cross edge, or something like that, or this is not even an edge. So they will ask you, given this, see, given the discovery time and the finish time, the number of DFS and the number of DFS are given, time numbers are given for the directed graph, and then they are saying, can you classify all the edges? What kind of edges are there? Seems like very good question, right? It is also easy question. Let's just see that how to solve this question. What you are going to do, you can easily make a chart for it, which means the interval chart. I think you can make. Once you make the interval chart, can you not make the Dfs tree also? Right? So see, once you make the interval chart, you can easily make the Dfs tree, and then you can just let's suppose the graph is given to you, or maybe like if they ask you that whether CA is a back edge or not. So once you have the Dfs tree, see, let's suppose you have a Dfs tree, something like this. Let's suppose you have, this is the Dfs tree that you have. After this interval chart, you can easily draw the Dfs tree. I hope that is fine to everyone. And this is the Dfs tree that we have. Now what they're asking is, they're asking that can you tell me what kind of edge is there? Let's suppose they'll ask you that what kind of edge is the CA. So if CA is one edge, then what kind of edge it will be there? Can you tell me? If this is the Dfs tree and CA is just one of the edge, then what kind of edge it will be? First of all, tell me, is the question clear to everyone? They have given the finish time and start time. They're asking you to classify the edges, right? Okay. So let's just see that how to do this question. So here first you draw the Dfs tree, and then you can easily comment out whether this edge is a back edge, whether this edge is a cross edge, or what kind of edge it is, right? So what are the steps? Make the interval chart, this is first step, and then make the forest or the tree, and then easily classify the edges. ये आ गया सबको समझ? Right? ठीक है. Now let's move to a different kind of question. So question 2 will be they will give you given the kind of edges, they will give you that okay, this is the tree edge or forward edge. Then they will ask you what kind of relationship is possible between start time and finish time. So for example, let's suppose this is the question. They are saying that for an edge UV, which of the following is true? If it is a tree edge, then is it okay to say that discovery time of u, it means discovery time of u is lesser than discovery time of v is lesser than discovery time of finish time of v. So it means finish time of b, it means discovery time of v, right? So it is lesser than finish time of v, it is lesser than finish time of u. So what they are asking is that if it is a tree edge, then is this true to have this? Tell me. Yeah, yes, Madhav, please ask. Yeah, Madhav, please directly write your doubt, right? It is unnecessarily communication that you are first saying I have a doubt. If you have a doubt, then please directly ask. Okay. Tell me, is this true or false? Is this true or false? This is not a tough question. Just see that which of the following are true or false. So they are saying that if it is a tree edge, then you will start first. If u is a tree edge, then you will start first. You will finish here, and then in between we will start and finish. if it is a triage. So you will start, and then somewhere you will be encountering V, you will be finishing the V. If UV is in a triage, which means first of all they are saying that UV is a triage. They are not asking you whether UV is an edge or not. They are saying it is an edge. For an edge, it is given that UV is an edge. Okay, so UV has to be an edge. Now what kind of edge it is, that you have to identify, right? So UV is an edge that is given to us. Now they are asking whether it is a if it is a triage. Now they are additionally giving you that okay, it is a triage. Then if it is a triage, which means let's suppose in the DFS tree, let's draw the DFS tree, that this is U, this is V. Then isn't it have to be true that you must have started U, and then you must have in between you must have started V, and then this must be the relationship between U and V? Isn't it have to be true? Right? Okay. Okay. Now let's see this question. If it is in forward edge, then this has to be the case, which means that if they are saying that it is in forward edge, which means it is not a tree edge. Maybe let's suppose it is given that it is not a tree edge. Let's suppose it is W or something, and then it is a forward edge. Maybe okay, maybe let's suppose it is V and it is U. They are saying that it is a forward edge. Maybe some edge is something like this. Now it is given to you, like this is what they are saying. It is given to you that this is a forward edge. Now they are asking the relationship between start time and finish time of U and V. This is the question. It is given that it is a forward edge. Now they are asking the relationship between start time and finish time. See, now what you will do, you will say you must have started this U, and then since it is a forward edge, which means it is a descendant of it, then you must have started this V somewhere here, and then you must have finished it because of the parenthesis theorem, and then you will be finishing this U. So the relationship between U and V will be same as this tree edge. That's okay. I mean that's fine. If it is a forward edge, then also it will hold this kind of relationship. Yes, this is also true. So this is true, and this is also true. This is also true. I hope that is fine to everyone. Now let's just see this question. In this question it is saying if it is a back edge, then this has to be true. So let's just see that if it is a back edge, which means let's suppose there is an edge which is going from V, like UV is a back edge, which means maybe let me put this U here because UV is a back edge, right? And then yeah, now it is a back edge. Now tell me what kind of relationship could have been between U and V. Let's just see if it is true. They are saying you will be starting V first of all. Yes, I think this is a descendant, so you have to start V first, and then you will be finishing U somewhere, right? In between you will be finishing U. So first you will be starting V, not U. This is what they are saying. See, earlier they said like you have to start U and then V. Now they are saying you have to start V and then U. Is this always true if it is a back edge? See, if it is a back edge, then this has to be ancestor because that's the definition of back edge, right? This is the definition of back edge, that if U is an back edge, then V is an ancestor and U is a descendant. So from this definition you can say that this is an ancestor and this is a descendant, like from the definition of back edge. Now what they are asking is that whether it is necessary to hold this kind of relationship. See, since it is ancestor, you must be starting this V, and then obviously if it is descendant, then obviously you have to start on the way. Like once you started this V, you have to encounter this U, because this U is reachable from V, because it is descendant, so it must be reachable. So once you start from start this V, you must be starting U also, because U is descendant, or you can say reachable basically. So here reachable is more important. Reachable from V. If you are starting V, then you must have to start this U, and obviously you will be finishing because of the parenthesis theorem, and that's how this relationship is also true. So that's why you will say that this relationship, which is basically the relationship between these time spans, is also true. So this is also true. What about this? They are saying if it is a cross edge, then V will be starting and U, like I mean this kind of relationship will hold. Is it true? If UV is on cross edge, not see UV means that this will be u and this will be v, not vu. So just tell me, if uv is in a cross edge, which means let's suppose this is some tree, and if uv is a cross edge, then maybe something like this will happen, right? Suppose something like this will happen, and uv means this is u, this is v. Then will you be starting v first or will you be starting u first? First tell me, if it is a cross edge, then which one you will be starting first, u or v? See, if you start this u, there is a big problem. Reason being is that if you start this u, then this edge will be just a tree edge. I mean, why will you not go through this edge? You will go through this edge, right? So you cannot start this u first. If you are starting this u first, since v is reachable, then it will become a tree edge. But they are saying it is a cross edge. That's what they are saying, right? So that's why you will say if it is a tree edge, if it is a cross edge, you cannot start this u. So that's why you have to start this v, and since this u is not reachable, so you will backtrack to parent or something, and then you will basically starting this u later. So that's why this kind of relationship will hold, where we will execute first and then u. So let's just see if it is true or false. Yes, v and then u. If they say that u v, if they just flip this out, then will it be true or false? So if they, let's suppose, if they have some kind of this relationship, then it will be false, right? Because you cannot have u first. That's very important here. Okay. So if they say this, then this is false. But if they say that you are starting v first, then this is definitely true. Let me know if you understood or not. Right? Okay. So in DFS, like for the directed and undirected graph, this is the edge classification. I hope that you remember that why cross edge and forward edge is not possible in case of undirected. I mean, in case of undirected, first of all, forward edge or back edge both are same. But we just say that, I mean, we can call these kind of edges either forward edge or back edge, doesn't matter, but we choose to call them as back edge, not as forward edge. And cross edge is not possible because see, if let's suppose this kind of edge is there, then obviously you will go from here, because everything is reachable from everyone. In case of undirected graph, it is not like that something is not reachable, so it will become a cross edge, right? It will not become a cross edge in case of undirected graph. That's the point. So that's why in case of undirected graph, there will no cross edge, because everything is reachable. Reason being is that everything is reachable. And there is no forward edge because we choose to call, because see, first of all, this kind of edge and this kind of both are same in case of undirected, because it is just this, right? There is no direction in case of undirected, so we choose to call them as back edge. Backward edge or back edge, both are fine, right? So this is also very important in solving some questions. Suppose if I say the graph is undirected, okay, let's suppose if I say the graph is undirected and there is a leaf node in DFS tree having degree 2. See, what I am saying is this. They are saying that there is an undirected graph and there is a leaf node in DFS that is having degree 2. Then does this necessarily mean does this mean undirected graph and there is a leaf node, let's say this leaf node is u, okay? So does this mean that u has a back edge too? So what they are saying is this, that there is an undirected graph and there is a node that is a leaf node in the DFS tree, and if you are having a leaf node, then if the node degree is 2, then see, there are only two type of edges. One is tree edge and one is back edge. If the degree is 2 and this is the leaf node, let's suppose this is a tree and this is a leaf node, and degree is 2, in the degree 2 in leaf node u in DFS tree, and having degree 2 in graph, basically in the graph, on the original graph it is having a degree of 2. Then what does this mean? See, this is the only tree edge that is possible, and in the original graph there might be some additional edges. And what kind of edges it will be? Since the degree is 2, it must be having one more edge. So it cannot have tree edge, because tree edges are definitely visible in the graph, in the DFS tree only. So it will be back edge. So don't worry, like we will be solving some similar concept tomorrow, and there is a very good PYQ that we will be using to solve this PYQ. I mean, we will be using this concept to solve that PYQ. There is very nice PYQ we will be solving later. So let's not worry about this particular concept. But yeah, in DFS, if it is undirected, it is either tree edge or back edge. Okay, just remember this. I mean, just understand this. Okay, I hope everyone understood. Now let's jump to PYQs. But I think as I promised you that we will not be having a longer session, so I think it is better to have PYQ tomorrow. So tomorrow today I have just revised the DFS, but tomorrow I will be just solving the PYQs only. So there are many nice PYQs that I have taken, and I will be solving those PYQs with the help of just simple theorems, like it is a back edge or not. It is a PYQ that I was talking about, that it is a DFS tree, and there is a I think there is a leaf node. Yeah, there is a leaf node that is having degree 2. So I was talking about this kind of PYQ earlier. So we will be solving these PYQs tomorrow. This is very nice PYQs, and we will be solving them tomorrow. Okay. If there is any doubt, you can comment it out, and you can also join the Telegram group, and you can ask your doubt here. Okay. Thank you everyone. Thank you so much. If there is any doubt, please let me know. If you have understood everything, then please tell me in the comment that you have understood everything. If there is any doubt, you can also comment it out in the comment section.